right? So we need to understand the entire data science and machine learning with respect to the life cycle, right? When you know more about life cycle of the data science and machine learning, you'll deep dive into the each and every business problem, understanding it very easily, right? So that's something which we are going to focus. Please everyone go on mute if you are not talking. Yeah. So here you can see in my screen, okay, there is a business understanding, model, data gathering, data deployment, and data source pipeline. This is the terminology generally we used to hear nowadays in the data science world, even if you talk the machine learning, right? So model building is modeling is one type of sector, the where we are going to focus ML algorithms and everything. Deployment is the cloud. Data acquisition, that's where data engineering and the big data, NoSQL databases and everything comes. So first one is the business understanding, the problem. So start with the business understanding. Then after that, gathering the data, which is very important from the different data sources, like different format of the files. Maybe data is from the SQL, NoSQL, like it's a big data, huge data, whatever it is. So basically, we are going to gather the data from these sources. And after that, once we have the data, we trying to go and do something called like doing something like analysis and doing some exploration and cleaning the data and everything. That data we are going to give it to the modeling here. So this modeling is very important. It's okay. So machine learning is part of the modeling, right? So of course, the understanding, business understanding, data acquisition, these are all okay. This is a first and second steps. Assume that. The third step is the modeling. Here the modeling is like many things come into the picture. So that is what we are going to spend next few days. So understanding the modeling, how, what are the algorithms, what types of machine learning algorithms, everything we are going to look into it. And I'm going to tell you one point here. I'm not discussing about deep learning at this moment. I'm going to focus only on the machine learning. There is a huge difference between the machine learning and deep learning models, right? So first, initially, we need to understand the basic idea of machine learning, right? So that's where like I'm going to invest more time with you guys on the modeling part. This is where like machine learning comes. Once you're done with the model, we are going to deploy that model into the cloud. Okay, so cloud we have the various source. Not only the cloud, we can also deploy that model into the dedicated servers, any Linux servers, any on-premises servers, whichever you use it, we can deploy there, and we're going to monitor that model. If the model is performing very well, then it's fine. If not, we are going to retrain the model again, we'll deploy it. This is something is called continuous integration and continuous development, which is part of the ML ops. Okay. Yes, Nazim, you want to talk?
Yeah, I've got a quick question to ask. So is this after we've sort of supposing we're is this when we know what the model's going to look like, or do we? I mean, for those that haven't actually seen a model, would they have to do some kind of requirements engineering and sort of gather requirements as to how the model should look like and what it should be doing from a requirements point of view?
Yes, exactly. That is always good to have. So if you understanding the problem statement, and also we can easily prefer the which kind of algorithm which suits for the modeling. So there are different types of algorithms are there. So if you know the problem statement very well, and we can easily tell that okay, this is the solution we can go into propose. So that's where like these arrow marks there. The business understanding with the modeling and business understanding giving the data. So business understanding is more important thing at the beginning stage. This is where like architects, like technical architects, these roles will come into the picture. They will decide that okay, what if data which we can use it for the building the models and everything here, right? Yeah, definitely. To answer your question, yeah, definitely we need to gather the requirements with respect to the modeling, and then after that we'll go and build the model. This is the life cycle. Generally, we use it. Right? So moving to the next one, this is the one of the architecture diagram from the Gartner. You know that Gartner is one of the research-oriented company. I mean, they used to do research, right, on the different technologies and everything. This is so the Gartner is proposing this is a machine learning development life cycle. So the one which you are seeing on my screen. So before going to talk about actual concepts, why I'm showing this architecture in the sense, you should understand the big picture. Look at the big picture. What is the part you are going to play here? right? That's the reason I am showing this is the big pictures. And you see that first one, of course, acquire the data is again the same story. Gather the data, and of course, yeah, so many things will come. Streaming the data is nothing but Kafka will come. Kafka is one of the most important tool as part of the data engineering. We use the Kafka, we use the Apache Spark. There are different tools will come here, right? And big data, source data is like structure, semi-structure, unstructured, many things. So if it is a batch processing, it is fine. Whenever it comes to the streaming data, that's where like message brokers, many things come into the involved, right? So acquire data is deals with the data engineering, the organize and analyze. This is the data analyst will come into the picture here. Of course, data scientist is going to play the role both organizing the data and deliver the model to the deployment process. Okay, this is where the whole process is going to be involved. So you are like, if you want to more focus on the machine learning models, you want to build machine learning, definitely your role is to be part of this organizing and analyzing the data and creating the model and trying the model and test the model. Of course, testing is more important. How your model is performing, that's where like performance measures to come into the picture. Finally, deliver the model into the like release the model for the usage purpose. Please go on mute. Okay, so the moving to the next one, MLOps, which is the most used term nowadays, and 20 and 21, and even for the future also, people used to talk about this MLOps, right? So why I'm talking these concepts at this moment, machine learning means, so understand the concept. So MLOps is nothing but a project structure in simple words. So MLOps is nothing but a project structure and how you are building your machine learning project in your organization. So tomorrow, if you are working with the clients, client will ask you what are the what are the project structure you are following it. So generally, we have the in the olden days waterfall model and agile methodology, and after that we came in. We have seen now DevOps, now MLOps. MLOps is a completely dedicated for the machine learning projects, right? How we are delivering the machine learning project to the clients. So how we are building the models, how we are delivering. See, that this MLOps is like continuously you build the model and continuously you train the model with the new data and deliver the model into the production environment. So MLOps is nothing but a project flow. Okay, in the project flow, you are going to work with the gathering the data and everything which you do it. So this is an important. The whole point in the previous slide and these slides, the first one, you should understand the data science architecture. Next one is the machine learning architecture, and the next one is the machine learning operations. This is where like you are going to deal with the project. Okay, so coming to the next one, machine learning operations and flow, which I'm not going to explain at this moment. It is a very heavy now because this is the whole flow. I'm not going to explain this entire flow here. This is where you are going to fit into the project. When you're going to work with some clients, some big projects in organizations, this is the whole flow which you are going to be. So training the pipeline, release pipeline. These are the two different things. There are the two different AI teams will be there when you are going to work in the real-time projects. So data engineering, code quality checks, data validation, train, validate model, and review and approve and register the model. And package is nothing but creating the model file. So once we created the model file, that model file only will go for the first to deploy into the test environment and integrated test environment. So everything is fine. Finally, you will move this model into the production environment. This is the flow, guys. It's not just simply go and go open the Jupyter notebook and do something like. Of course, that is a part of development, but actual flow of machine learning is like this: gather the data and do the data engineering and do the validation of the data and train the model, validate the model, and get approvals. This is not like by we assume that the model is working fine. Tomorrow, what if there is a new data comes? How we going to deal with this? Lot of things come into the picture. So just look at the terminology: training pipeline, release pipeline. I'm going to talk about these pipelines after we're done with some understanding about the algorithms. This is not the time to discuss in depth of this machine learning and operations, but I'm just giving the overview what actually we are going to do with our part of this entire sessions, right? First, we'll try to understand each and every concept, then we'll move on to the building the each and every model with respect to the real time experience. This is what the flow. So this is what the flow which we are going to do it. Okay. So any questions you have in the previous slide? These slides, do you have any questions? Anyone? So I'm just giving the idea like what actually we want to learn here. Okay. So coming to the actual point on today's session. So let's talk about artificial intelligence, right? So artificial intelligence, which is because I'm not going to talk about the definitions here. You can find definitions anywhere in the internet world. So artificial intelligence, why we are going to talk about, there is a two important reasons. The main reason is the data. When we have the so much of data, and what we are going to do with that data, we need to build very effective technology, right? That's where like we use the technology, data and technology. That's where like AI is coming to the picture, right? So even AI is there in the 1960s or like 1970s. But why we are talking about AI nowadays, it's because of data. That is, everybody knows that fact, right? So AI is nothing but a technology which we apply on the data. Whether you do the analysis, you build the models, whatever you do it, okay? But act as the intelligence system, basically, right? That's where like AI is coming to the picture. AI is mainly at the technology part, and data science is at the data side part, okay? But we are doing both the combinations here, data science and AI. So we need to be connected both, okay? Data science and AI is always be connected, right? So technology part we are going to focus now in the machine learning side. So coming to the next important slide, this is a very, very important slide which I'm going to deliver to you. The first thing is CS means computer science. The where AI comes. So computer science is actually deals with entire about computer related technologies and everything, right? Under the computer science, we have the artificial intelligence. Under the artificial intelligence, there is a symbolic learning, and another learning name is called the machine learning. Actually, the machine learning and symbolic learning, these are the two types of learnings as part of the artificial intelligence, and we are going to mostly focus on to the machine learning part. In the machine learning part, again, there is a two important parts. One is a statistical learning, another one is the deep learning. Okay. So this is how the hierarchy goes, right? So computer science, artificial intelligence. Under the artificial intelligence, there is a two learnings, symbolic and machine learning. Under the machine learning, there is something called statistical learning and deep learning. And come to this symbolic learning, so we mostly deal with the computer vision. The another one is the robotics. Of course, we use robotics directly here, and only Japanese companies are investing more time onto understanding this robotics concepts here, right, in the symbolic learning. And coming to the another point here, okay, NLP. So when I'm going to talk about NLP, NLP is a part of statistical learning, and there is a speech recognition which is also part of the statistical learning. The mainly we can say that. The another part of the deep learning is neural networks. This is like the hierarchy, which I can say that. So neural network is the sub element of deep learning, and deep learning is again the sub element of machine learning. Again, machine learning is sub element of artificial intelligence. Like this tree will go, and there will be a question from your end, why you are putting the computer vision under the symbolic learning, right? I will tell you one thing. Okay. So computer vision deals with the image processing, and machine learning mostly deal with the pattern recognition. Remember guys, symbolic learning deals with the image processing, and machine learning deals with mostly with respect to the pattern recognition. So computer vision is also part of symbolic learning, and as well as the it is also part of deep learning, we can say that. And computer vision, we can say, also part of deep learning. When it comes to the CNN, I'm not talking about here algorithms. I'm not about algorithms here. And if you talk about deep learning, there is a CNN, RNN, ANN, and auto encoders. Many things will be there. I'm not bringing that. I'm showing that high level architecture of the where the machine learning is there, what kind of things we are going to learn. So I'm going to start in the next couple of days. We are going to talk about only machine learning. I'm not talking about deep learning. I'm not talking about neural networks. I'm not discussing about computer vision. I'm not discussing about natural language processing, because everything is, you need to be specialized to get the knowledge. Okay. Everything is a different stream. You need to select where you want to become. So machine learning is not going to help you anything. This is just a foundational skill for you. But in organizations, we build deep learning solutions, we build NLP solutions, we build speech recognition solutions, computer vision solutions. But machine learning is just like a basic, a foundation to you to learn the machine learning, I mean, deep learning and in effective manner. Okay. And we don't use the machine learning in the real-time projects nowadays because most of the models which we are building on the deep learning and the neural networks, of course, which we use the keras in general, and statistical learning, there is a speech recognition and natural language processing, the computer vision and robotics under the symbolic learning. This is where like we generally go with the flow. Hope you are getting the clarity what I am talking. Do you have any questions, guys? Anybody here? Anyone have any questions?
So what is NLP and speech recognition?
You,
have a question.
I don't know. I'm not. Can you say again?
Do you hear me?
Yeah. Yes. Go ahead, please.
Okay. Where is the location of the computer science in the AI or ML?
Where is the location of?
Computer science. So when we use computer science or software engineering,
Okay, so that is like a general question, right? I don't think so that is related to the machine learning. So when we use the computer engineering or software engineering, right? Okay, software engineering is the methodology where you are going to follow the, in general, SDLC, software development lifecycle, to build the applications in the computer languages, whether you use the C, C++, Java, .NET and everything. So, computer science and software engineering is kind of how you build the products in like computer products, computer softwares, something like that. So I don't know whether this question is can be relevant to this machine learning concept. So in general we can say that software engineering is kind of a methodologies which we follow to build the software products. It's kind of a protocols and everything. Yeah.
Brother, can you please elaborate NLP and speech recognition?
Yeah, NLP is okay. Let me give an examples like NLP. Can you please tell me chatbots is part of NLP or speech recognition? Anybody here? I mean, simple chatbots. You take Alexa, you take Apple Siri, or anything which you take. So, can you please tell me these are part of NLP or speech recognition?
NLP for sure.
Both. Wouldn't you say both?
Pipe? What is pipe?
Both. I mean, both. As like, yeah, it has elements of both.
Yeah. Okay, let me tell you. Okay, so speech recognition is a technology that enables the computers to identify the interpret words and phrases in the spoken language, and those words is converting them into the text by computers. That's where we use the speech recognition, which is a subfield of the computational linguistics, and it deals with the technologies and everything. Right? When it comes to the natural language processing, which mainly deals with the human communication, okay, which is the branch of artificial intelligence, as I said, it is mainly deals with human communications. So NLP is for the human communications. And what about the speech recognition? Speech recognition, which is like a technology enables to computers to identify the interpret words and phrases which we talk generally in the spoken language. Those will be converted into the text. So basically, we are recognizing basically recognizing the words where the human speaks, basically, right? That's where like that comes. Natural language processing, which is deals with human communications. When I say human communication, means anybody guess what is a human communication generally? So when I ask the Siri to play a song, it will play, right? It's a human communications. Okay. When ask do something activities like something, when you deal with that, okay, any chatbots or something, that's where like NLP comes. Even if you're not talking, even if you type something in the chatbot, it will give an answer, right? It's not only deal with the speech. Even if you type, if you want to book an appointment nowadays to doctors, if you go to the chatbot and ask doctor appointment availability and everything, you type something and it will respond everything it will give. So that is also part of NLP. In simple words, I can say that NLP is equal to Okay, speech recognition plus, and everything is comes basically. Even speech recognition also part of NLP. But when you're dealing with the big subject, and speech recognition is a separate, what I can say, separate branch. We can say that. Okay, mainly. So NLP is like both. You can speak, and also you can write something. It will convert that terms into the human computer understandable language. Okay. So moving to the next one. Okay. So next one. So this is the whole picture, guys, and there will be a lot of other components also there in AI. I'm not saying that this is this is the complete one, but what my point is that this is, I'm just giving the where ML is there and where what we are learning here, and the picture is the big picture, and I will show you when I am going to talk about deep learning. And this same picture I will add some more AI components, AI branches. You'll get more clarity on it. So as of now, this information is pretty cool and enough for you to understand where ML, where statistical learning and everything. So ML deals with the pattern recognition. Symbolic learning deals with the image processing. We deal with mostly images. Okay, that's where something will come now. So moving to the next one. So our topic is machine learning, right? This is now we are going to start. So machine learning is the main topic which we are going to talk about. When I'm going to talk about machine learning, you can look at this, okay, this diagram. You see that in 1950s onwards, the artificial intelligence came, and when you after 1980s, machine learning came into the picture. In 2010 onwards, deep learning came into the picture. This is the year evolution of deep learning, evolution of artificial intelligence. Of course, machine learning and deep learning came little later, okay, after artificial intelligence only. This is the information you can see. And anybody have any questions here? Right? Okay, so this is how like the evaluation is there. Of course, you can see this artificial intelligence is excitement, machine learning begins to the flourish, and deep learning breaks through the like drive AI algorithms, AI boom or something like this. So coming to the introduction part, there is so many definitions are there when it comes to the machine learning. Okay, absolutely, there are many definitions. Okay, so machine learning is the study of computer algorithm that improves, and a lot of definitions are there. As for the Arthur Samuel, in 1959, he proposed that so machine learning is something like field of study that gives the computers that ability to learn without being explicitly programmed. So that's where like machine learning come into the picture. So definitions and all you can study from internet. That's not a big deal. So you study now, you learn now also. Maybe tomorrow you forget. So basically, machine learning means like it understanding the data and learn from the historical data, okay, and behaves with respect to the new data in the future. In simple words, we can say. Okay, so coming to the point here, what are the machine learning approaches we generally follow? Some of the textbooks, some of the websites, they say that types of machine learning. There is no types of machine learning, guys. Okay, there is no types basically. Approaches are there. We can use the correct term. Okay, there are different approaches we follow in the machine learning. That is a supervised learning, unsupervised learning, reinforcement learning. Generally, as for the academics subject, we deal with supervised, unsupervised, and reinforcement. And there is another things also there, semi-supervised learning, and another one is the self-learning. And there are other more thing, robotics learning. Different things are coming now. Even Facebook also recently they are talking about more onto the self-learning. New things are coming, but future is all about self-supervised learning. Okay, the future is all about self-supervised learning. That's where like Facebook, Google is investing a lot. And recently they released some white papers in their official websites, ai.facebook.com, and you can go check that. Recently there is a Facebook is released one white paper on the self supervised learning, which is going to be a future. That's what they are believing. These are the different approaches we have it in the machine learning. Generally, we study like supervised, unsupervised, these things only, but there are a lot of things which we can understand in different way, right? So coming to the next one, what are the machine learning applications. Nowadays everybody can say that there are different types of applications are there. Okay, so for example, these are the applications we can use the machine learning in the retail, finance, manufacturing, insurance, medicine, telecommunications, bioinformatics, web mining. Many places we use the machine learning. There is no one place like we can say that. So online fraud detections and stock market trading and medical diagnosis, automatic language translations, image recognition, speech recognition, traffic predictions. I don't know which company is the best, which country is the best country using the AI for their traffic predictions. Anybody knows here? There is one country in the world that using the very effective traffic predictions, and almost all that is the 95% of it is predicting in their country. So anybody knows that answer? So if
Singapore?
anybody go and find that, give me proper answer in our WhatsApp group chat after this session. Okay, so
Yeah, exactly.
anybody, yeah, find out and let me know. I'm asking question like which country is actually developed the effective traffic prediction. Okay, and it's really amazing. It's predict more than 90% of that. Okay, fine. These are the some of the examples of machine learning applications. And nowadays everybody knows even YouTube recommendations, even Netflix recommendation, that is also part of one of the machine learning applications, we can say. Even Siri, there are many things out there. Okay, and so it depends what industry you are choosing, where you are going to focus, and how you are building the machine learnings and everything, right? Okay, coming to the point, next one. So okay, so this is a little different. When I'm going to learn the machine learning, okay, what kind of things I need to focus? This is someone asked the question in the our group chat today also. Main important thing when you are going to see this headline is little wrong here. Okay, forgot about that. So machine learning is mainly deals with the study of algorithms. I'm talking at the developer's perspective. Okay, don't look at the business here. Just look at the developer's perspective. What exactly we can do it here as an individual. So we need to understand the algorithms, study of algorithms, right? Improve their performance. Their performance means machine learning models. We need to how far we can improve. What are the various performance measures we can consider to improve our the machine learning model, and what is the study of algorithms? All these things comes here. Optimizing and performance criterion using the examples, data, and fast experience. And this is a continuous training the model. Role of statistics and role of computer science plays very important role in the machine learning, right? Statistics are very important, especially on the sample data. Of course, we don't do on the complete whole data, we use the sample data only, right? When you have the 30 terabytes of data, or else like 300 million terabytes of the data, if you have, are you going to do analysis on the 300 terabytes of the data in the real time? It's not possible. Even you can't visualize the data also. So in that case, how we are going to do? We use the inferential statistics, and there we are going to take some sample data and we'll draw some conclusions. That's where like hypothesis testing, t-testing, there are many things will be there. We are going to prove that help of those algorithms, those theorems, say that, okay, these are the conclusions, these are the assumptions are true, we can prove that. That's where like statistics going to play a very big role. Statistics is going to help you to prove the assumptions which you made on top of the data which is the sample data. Of course, that is the inferential statistics. Okay, okay, not the descriptive statistics. And the role of computer science is the efficient algorithms to solve the optimization problem and representing and evaluating the model for the inference. So we'll get to know this, how we can optimize the model, what are the different techniques we use to optimize the model, and what are the different ways we can evaluate the model, and come to the supervised learning, unsupervised learning, how we are going to deal those things which we are going to discuss. Fine. So coming to the machine learning model, what exactly we focus here? Train the model, select the algorithm, train the model, package the model. That means create model file and validate the model. And actually the thing is that in this diagram, what I don't like is the validate model should come before package model. First you train the model, then validate the model. This validate is nothing but unit testing, a developer testing. And once you do validate here, then go to the package. Now, once you package, then you deploy and monitor the model. If you find something your model is not performing well, and you need to retrain the model, and again do the validate, package, deploy, and this is something called continuously a machine learning engineer do that role in the organization. Okay, so of course there is a lots of data comes, we need to train the model and in effective way, and finally we need to deploy and monitor the models. And you can see here also there is a training, and this is a complete another cycle, model life cycle. This is not machine learning life cycle, this is called model life cycle. There is a difference between the machine learning life cycle and model life cycle. Okay, this is only about modeling, how you generally build the model, right? So like model evaluation and productionize the model, testing, deployment, monitoring and observability, many different things will come. But we are going to discuss one by one when we consider the each algorithm, how we are going to uh, write different test cases. I don't know how many of you know about machine learning test cases, but yeah, we are going to learn here how to test the machine learning models is okay, but writing the test cases for the machine learning model, that's something we are going to learn in effective manner. Okay, so coming to the next point, so here this is the question. There is a three types, or we can say in other words, three approaches of machine learning. So we are going to focus. So first, next 2 weeks, we are going to spend time on the two. Here you can see supervised learning, unsupervised learning, reinforcement learning. You just put reinforcement learning aside. Okay, that is we are going to talk into the advanced machine learning. We are going to learn this thing, reinforcement learning. So initially we are going to focus on the supervised and unsupervised. Supervised learning is going to deal with the data with the labels. Unsupervised learning is deals with data without labels, right? Reinforcement learning is actually like considering the data in terms of states and actions, right? That's where like it's like environmental learning, right? Reinforcement learning is something called like it is part of environmental learning. Okay, so coming to the point is, what is the main differences between the supervised and unsupervised learning? Anybody tell me? Apart from the labels data, we know that supervised learning algorithms are trained using the label data, unsupervised learning algorithms are trained using the unlabeled data, right? So one more important point in the supervised learning, the model takes direct feedback to check if it is predicting the correct output or not. And unsupervised learning models does not take any feedback. Okay, that's something we can say. Supervised learning models predicts the output directly. Unsupervised learning models finds the hidden patterns in the data. So if I go and give the more definition, more differences, you may get little confused. You may feel like a little tedious. But I'm going to talk this one by one. We'll take first supervised learning. We'll focus on that. We'll build algorithms on the supervised learning with the practical examination, practical examples. Then after that, we'll go to the unsupervised learning. Again, we'll go and build the practical examples. Like that, step by step, we'll go. Then you finally will understand here. So very simple, I'm going to tell you here. The goal of supervised learning is to train the model so that it can predict the output when it is given new data. And the goal of unsupervised learning is to find the hidden patterns, useful and insights from the unknown, okay, unknown new data which we give into that. Okay, so that's where like this label means. Anybody tell me what is the label? Anyone tell me what is the label?
Target value.
Yeah. So okay, in simple language we can say target value. So you know input and output. You know, I mean, when the in the sense when the model you are training, when you are training a model, when you are training the artificial intelligence model or machine learning model, the model knows the both input and output. Then finally it gives the like, okay, what is the output? If any new data comes, it will say that this is something X or something Y. Assume that you are giving the, okay, let me give a easiest example. Everybody says like that. You are giving the cat images and dog images to the supervisor learning, and you are telling that this is the cat. When you see the cat image, whenever the model sees the dog images and there is a dog, it is giving that it is a dog. So both input output we are giving to the model. The model understands, okay, this is the input, there is a dog, and output is also dog. This is the input is like the cat, and output in the sense I mean to say that label data. In the label data, in the historical data, we know input and output. And the same way we are training the model. And if new data comes, it will predict the same manner. But when it comes to the unsupervised learning, we don't know output. We give only input data, right? That time only, like what will come, like there is something called clustering as association problems will come. Of course, that thing we can discuss in deep. Of course, these concepts we are going to discuss deep dive into the each and every algorithm. Will get more clarity. So we know output in the when you train the model. Supervised learning, unsupervised learning, we don't know what is the output, but we train the model based on the different patterns we use here. Okay, unknown data sets. So any questions here? But anyway, I'm going to talk about this in the future sessions. You will get more clarity. So this is another diagram which I taken from the internet images source, and you see that the machine learning, which is divided supervised and unsupervised learning. Here in this diagram, I'm talking about algorithms. Supervised learning is basically divided into the two types. Okay, so classification and regression. Okay, so let me take here. Okay, just going to take. Okay, yeah, you can see here there is a regression. I hope you are able to see regression. Another one is the classification. These are the two types. So when I'm going to talk about supervised learning, the regression and classification are the two problems. When it comes to the unsupervised learning, the clustering, the another one is the association problems. This is the one. Okay, generally we can take. These are the two main problems we deal with unsupervised learning. Of course, there is always like two types of data which we understand in the statistics. Statistics like continuous data and categorical data. This is what we already studied, right? The continuous data and categorical data. Okay, so this is we already studied when it comes to the status types of the data. We already spoken in the earlier sessions. So the same thing we are going to apply. So when it comes to the continuous data, we use the regression and clustering. When it comes to the categorical data, we use both the classification and association. The classification is under the supervised and association is under the unsupervised. Okay, so this is the flow, and of course there is a different types of algorithms are there: linear algorithm, linear regression, polynomial regression, KNN, trees, logistic regression, navy Bayes, support vector mission. Many things are there. One algorithm will take one problem, will solve. We will take the data set from the Kaggle or different other sources. We'll try to make it possible in each session. So that's how it is. Just remember, there is 5 types. Generally, we talk about approaches of machine learning: supervised, unsupervised, reinforcement, semi-supervised, and self-learning. And supervised learning, we have the regression and classification. And unsupervised, we have the clustering and association. And of course, both the deals with the two different types of the data. That's like continuous and categorical data. Okay. So anyway, I'm going to share this documentation with you. Don't worry. So mostly I will try to share tomorrow, even after the session if possible, if I have some time. Okay. So coming to the next one, this is another diagram, which is also I have taken from the Google. The machine learning supervised, unsupervised reinforcement learning is a simple manner, which is mentioned here. The classification, regression, and also neural networks, some other different diagram here, but the types are same only. Okay, classification, regression, clustering and association, and reinforcement learning is decision making. That's where like Q learning, R learning, TD learning, these are the different learnings will come. And I don't know, I think nowadays some the people from the New York University and Stanford University, there are students are investing more time on to understanding the reinforcement learning, because there is no any effective I mean to say that very less projects are there on the reinforcement learning. Even the skills set is also very less. Finding the resources on the reinforcement learning is very less. So if anybody is interested to focus on the reinforcement learning, you take this subject. It's really interesting. And this area is like, it's a little different. People never talk much onto the reinforcement learning, which is mainly deals with the robotics, some kind of environmental study, understanding the environments, building the models and all, decision making and all. So this is a little tough subject. Interested, you can just take this one as your career path, focus on that. Okay. So coming to the point here, yeah, as per the recent studies, top 10 algorithms and methods used by data scientists. Of course, regression is the most used the problem statements. It is like it is a survey uh, conducted by the KDD Nuggets, and there is another organizations which they conducted, and data science are giving this answer. This regression is the first one, and clustering is the next. Decision tree, visualization, k-nearest neighbors, and PCA. PCA is like principal component analysis, statistics, random forest, time series problem, text mining. So these are the the main top 10 algorithms, and data science is already chosen. And also so these are the some of the information which I've shared with you. So what is our next aim is going to start begin with. So I want people to download the Jupyter notebook, okay, and VS Code. Jupyter notebook is for, like as I said earlier, we are going to use the Jupyter notebook for the data analysis and visualization. And I want someone to download the PyCharm or VS Code. Okay, these are the things we need actually. This is for the user interface development. So once you're done with the model analysis and everything, we need to convert that. We need to create a package file. So to create a package file, generally old methodology is the pickling. Pickling is nothing but serialization process which we use. Pickling, you are creating the model. So once you train the model, once you get good results, okay, so that is all about development. So we need to do like creating the package by using the pickling and other sources. And there are many ways we can do it. I will tell you other techniques. And once we have the model file, and that model file we use the VS Code or PyCharm, and we are going to use the Django, or if it is a big project we use the Django, otherwise we'll go with the Flask. Even if you think of Flask which is not your skill, and we can go and use the different things. Anybody tell me what are other things are there other than Django and Flask? Anybody? Already I spoken right in the last year.
Fast API.
Yeah, exactly. The fast API is, it's kind of we can say fast API. What else is there? Streamlit, right? Streamlit is one of the very powerful tool. Okay, if you don't know Flask and Django, don't worry. You can easily use this pickling art model by using the Streamlit. Streamlit you can learn within a day also. Okay, if you are capable of learning, Streamlit can be learned within 2 days also. You don't need to worry about it. Just go in their documentation. Even I created one video, or else you can go to their documentation. You just copy their code in the VS Code, install the pip install Streamlit, and use their code. You can easily see it. So it's not a big deal. For simple one-page website, we don't need to learn entire Flask and Django. If you are more than Streamlit is more than enough to use the model. So what my point is that this is this VS Code and all, we are going to use it for the user interface. Okay, this is for the model building, model analysis and model building. Once model is there, then create a package and use that package in the fast API. And tomorrow, if new data, if you pass from the when you pass the data from the user interface, we need to give the predict results, and that's where we are going to. But this data you can first look at in your local computer. I mean, everything is fine. Then you can go to the deploy into the like DistilOcean, AWS, Google Cloud Platform, GCP, or we can go to the Heroku. Different platforms are there. But anyway, I will explain you all these things. But just keep in your mind, we are going to build end-to-end machine learning projects, not just Jupyter. But of course, in next 2 weeks, we are going to spend only on the Jupyter to understand the models, to understand the algorithms, how to do the analysis and everything. So when I'm going to start at the beginning only, you'll be confused. So first 2 weeks, we are going to focus on the Jupyter. Then after that, whatever the models we are created, those models will be creating the package files. And after that, I will use those packages file the user interface. And after that, we'll go into place into the deployment, and we can see that how things goes. Any questions?
No.
So what would be the next chapter? What would be the next concept tomorrow? We are going to begin with supervised learning, and we'll take starts with the classification problems or regression problems. So I'm planning to start with regression or classification. Anything is fine to me, but I'm looking at the beginner's perspective. Better always people will take regression problems when talk about beginner's guide. Always people take regression problems first. So we'll see that we'll take regression problems only at the first. After that, we'll move to the classifications. Your choice, guys. I'm fine. Okay, so generally with the flow people will take regression problems for the beginners. Okay, otherwise classification is also fine. So we'll start with one algorithm tomorrow only. So every day hopefully we'll try to finish one algorithm. If not possible, within 2 days one algorithm, one problem statement, will solve it. Okay, so as quickly as possible we'll solve it, and that's where like we are going to be that. So our aim is going to create one concept, one project, as in that support vector mission, one data set, one project. Please go on mute, guys. Or is not on mute, please go on mute. Please help me. Okay, so next thing is what I'm telling here. So tomorrow we are going to take supervisor learning, and there one algorithm, one data set, and we'll start. So I don't want to go with the house predictions. Okay, and this is like very the common things people do. Let's go take the different data sets and we'll try to build it. But tomorrow little like understanding the entire. Okay, coming to the point, what we are going to use the tools. If anybody don't know about this is the first time you are going to learn the machine learning in this group, and what I'm going to do, right, go to the Anaconda platform. Anaconda is one of the data science and machine learning platform. Okay, so go here and download the free version. Okay, most of the people knows. If anybody don't know, okay, if anybody is not done yet, go and download the Anaconda, and whichever the operating system use, you can download it. Okay, so there is a community edition, there is a multiple editions are there. You just download the community edition only. Okay, not the enterprise edition. So I don't know if people already done, that would be great. If not, okay, and you can do it. So just download this. And important thing, very important thing, when you use the Anaconda, especially like Anaconda Jupyter, and it comes with the Python 3.8 only. Still Anaconda is not integrated with 3.9. As we know that the current version of the Python is 3.9, but still Anaconda Jupyter notebook, this environment is not with 3.9. Hope you understand. When it goes to the Google Colab, there is also like 3.7 only. When you go to the Google Colab, and they use the 3.7, and it comes to the Anaconda 3.8. How many of you know about the Google Colab here? It's another product from the Google. You don't need to download the any software. We can use the Google Colab. This is cloud based tool, cloud based Jupyter notebook, we can say. So okay, open it, no problem. Yeah, this is how it will be there. So okay, we can use this Google Colab to write a program. If you think, okay, I don't want to install anything, do the setup and everything in your system, don't worry, you can use the Google Collaboratory. We can use it. This is how it works as well. Okay, but these programs we can see it later. I'm going to use the Google Colab for the deep learning problem statements, because that's where we use the GPUs and TPUs. But as of now, we are going to use only Anaconda platform for our sessions. So please download Anaconda. Okay, go to this website and download it. When you go and download this, and you just go to the search bar, you'll find this Anaconda. And the latest version of the Anaconda, which they already installed, the NumPy, SciPy, Matplotlib, Seaborn, and Pandas. So you don't need to go and explicitly install it. Already they installed in the latest version of the Anaconda, because now they are under the package. I'm not seeing the messages. Okay. So any questions do you have?
Hello.
Yeah.
Yeah, so if I wanted to learn Django, considering I do have OOP knowledge of Python, how much time would it take?
Django, right?
Yeah.
It depends. Okay. So first in Django, when you understand the architecture, you'll finish it in within 30 days. I mean 25 to 30 days. If you're not understanding the architecture, the flow, even it will take 6 months, 1 year also. The
Okay.
flow is very important. There is a URLs to the models to the views to the HTML page, something like this. So
So
30
for
days.
this course, I should use Fast API to learn quick.
Yeah, see, if you are more focused on the machine learning side, Fast API is fine, or like Streamlit is fine. So I preferred like Flask is the best choice because still in the organizations, most of the organizations use the Flask for the 2 pages or 3 pages of AI projects. They use the Flask a lot. Okay, because Flask is the community is a big compared to the Fast API. Even if you go to the Google and type it, the differences between the Fast API and Flask, and the community is more under the Flask, and more applications are building outside. But Fast API is very efficient because when it comes to the REST service, web services, Fast API we can use it for the different formats, not only for the REST services, we can also use for the another services. Okay, like GraphQL, and those are the services we can use it. Fast API is very highly advanced toolkit, okay, in the machine learning platform. Okay, but Flask is, it is a mostly used one. There is a difference, the mostly used one and a highly advanced one. It is a choice yours, which one you are going to choose. Fast API is not a big deal to learn, okay, and Flask is very important, especially for when you go to the organizations. Mostly they use that one only. Personal projects, it's up to you. Yeah, and Django is not. I don't think so. People use a lot Django for the machine learning projects. Django is mainly for the other side of other side of the projects like e-commerce or something like CRM projects. Some kind of projects we use it. Okay, but machine learning projects we use the Flask a lot. Okay, yeah. So any questions? I don't know. I already created Django videos. Okay, already created Django REST framework videos. Already I've done with that part. If you can go and check that. And Flask, we'll see that within our sessions only, we are going to deal with Flask, which is especially for the machine learning. Okay, okay. Regarding the tools, I want you to install the Anaconda. Okay, with Anaconda, there is a many tools will come here, like the Spider. And Spider is a very interesting tool if you use it. Okay, and the notebook, and of course nowadays PyCharm is also included here. I mean, 2 years back no PyCharm in this, and the VS Code is there, and R Studio anyway we don't want. Okay, and the Jupyter Lab is also there, Jupyter Notebook. So we are going to use the Jupyter Notebook, and I don't think so. I believe that everybody knows here in this session. I mean, here in the flat in this session. If not, please download it and get it ready here. Okay. So anyway, we are going because we already done some sessions on this Jupyter Notebook earlier, like Pandas, Dask, and we are done something like Matplotlib, Seaborn, and Plotly. All these things which we already done. Bokeh. With these things we are done in the earlier. So what we are going to do, right? We are going to use the same tools to the analysis and visualizations. When after that we'll build the models and everything. Yeah. So any questions? Okay, so if anybody wants, like, I don't know, because today there is a new people are joined here. I don't want to say like this is like already I given the one of the repositories for the AI and data science. These are the lot of repositories are there. Already I shared with you guys. Okay, I'm planning to share again this file in the PDF format, so you can take it up. These are all like different sheets, and there is a different GitHub accounts like for the projects and codes, and many things are there here. And these entire thing which already shared to the earlier, because I have seen that many people like 20 people 30 people are joined today in our community. I want to share them with this content again. I will share this PDF file in our WhatsApp group again, so you can take it. Okay, so any questions? I'm just reading that chart here. I know about that free cloud which provides UI interface. Does we have to learn Linux? Yes. If you learn Linux is always good. Compared to Windows, Linux is a great platform. Better to learn. But don't learn too much things. Go with your direction. What is your direction? Are you going to be a machine learning engineer, or in the AI side, or like deep learning engineer, neural network side? Are you going to be an NLP engineer? Okay. So you have to decide what is your path. So don't try to mix up everything, and see, you have to specialize in one area first, then you go and explore whatever the way you want. Okay. So tomorrow in AI we can't go and learn everything within a year. We can't say like we know everything, right? We need to be specialized in one area. Okay. So that you have to choose by your own based on your background and your interest and what is your aspiration and all, right? Fine. So any other questions, guys? I really thank you so much, guys. So many people joined today. This really gives more motivation to move forward in this sessions. Okay.
That was really good. Thank you.
Yeah. Okay. Fine. I want to learn deep learning with a specific project of image captioning, but it seems everything is world and domain. What do you suggest? What is volt? See, okay, if you want to be more like advanced things, of course you know this the most the great website. I don't think so any website can beat papers with code nowadays. So it is far better than any other platform, right? So you can go to here. If you see, I don't know how many of you know the meaning of state of the art. Anybody knows here? Anyone know the meaning of the state of the art?
Yeah, the best model or the best technology.
One answer. Anybody else? I got one answer. State of the art.
Not
You
sure,
are
but I think it might be something like a bit more creative than usual.
exactly. Both answers are almost all correct. That's right. This is actually introduced by the Cambridge University. Okay, first time Cambridge University was introduced this. State of the art is nothing but a research paper. Okay, really that's something which is not in reality built 100%. It's like a proposal. Okay, so sometimes it's like cutting edge technology, we can say that. Okay, so it's like something new paper and new concept which came into the market. This is the common terminology people use in the machine learning world. Don't ever say like I don't know state of the art. State of the art means it is a something new, and which is a new white paper, new technique or new approach, like new development or new advice, you can say like that. Okay.
Is
It's
it when you not use the word innovative, innovation?
innovation,
Like
yeah, we can say that.
a lot of
Yeah,
technology companies tend to use innovation these days.
yeah,
Um,
exactly. You're right. You can say innovation, simple word. Yeah. So, but we need to be careful because every state of the art is not 100% verified. It's up to you, like, okay. So why I'm here in this, because there is a question in the chart. Okay. And I want to learn deep learning with the specific project of, so you can go and look at there is a very high, okay, I'm talking about go to the state of the art. In the state of the art only, go to and select which domain you want to be, like computer vision, natural language processing, or medical methodology. And there are many here: speech, playing games, time series. And you select which one you want. These papers are like highly advanced, and it's really really worth. You can spend your time this year, whole year, and build one paper, and you can submit these papers. These papers are very like next level. And of course, interesting point is that there is already code, right? So these papers is already with some code. You can see there is a piano related one. Okay, piano MIDI, and there is a 11,086 piano pieces from the different. Yes, who is messaging you? Yeah, so yeah, data sets also there. We can predict there is a source code also there given. You try with this. So state of the art is very important for the machine learning standpoint. Okay, these are the new innovations, new things which you can explore. Because if you think anything, any concept which is old, and better to come to the state of the art and try to do. This is a very good, great community, guys. Okay, this is a great community papers with code, and also try with this. And these people are already there in the Slack. Already I joined in the Slack also. You can also join in the Slack. I don't know how many of you know about the Slack. So better go and join in the Slack here. Where is that? Here, sorry. Join the Slack, and there is a huge community in the machine learning platform, and join there. and there is a lot of discussions are going on. Okay, so this is a better way to get into it. Already I joined in this, but the problem here, you will not see the old information until you pay. Only last 7 months information only you can see. Sorry, 7 weeks. That is also wrong. 7 days. Last 7 days information only you are going to see it. Still, if you want historical data, you have to buy. You have to buy the space here. So this is a really great platform. I strongly recommend you go and join here. You can see here, and March 17th before data, if you want, you have to upgrade the current the package. Okay, so I hope you will check this one. There is a lot of things is going on here with the community, so hope this is you like it. Go and join. Okay. Can you share the link of the Slack? Yeah, definitely. See here only there. Okay, wrappers with the cloud Slack. Okay, I'm just going to ping you on the chart. If you go to their website only, there is a right side of the page. You will see the Slack, and you can take it up that. Okay. So, any questions, guys?